Welcome to Episode 5, ConfigMaps and Secrets. Today, we tackle one of the most important practical skills in Kubernetes: how to manage application configuration and sensitive data safely, cleanly, and at scale, the right way. The number one mistake developers make when containerizing applications is baking config directly into the image. Hard-coded database passwords, API keys, environment flags, all sitting in your source code and Git history. It's a security disaster, and it makes your image impossible to reuse across environments. ConfigMap is Kubernetes' solution for non-sensitive configuration. It's a key-value store that lives inside the cluster. Your pod reads from it at runtime, so the same Docker image works in dev, staging, and production, each environment just using a different config map. You can even store entire config files like nginx.co/nf as a single key. There are two ways to consume a config map. First, inject specific keys as environment variables. Your app reads them with process. env or os.ge10 works with any language. Second, mount the whole config map as a directory of files where each key becomes a file. Volume mounts have a bonus. When you update the config map, the files change automatically without needing a pod restart. For sensitive data, passwords, API tokens, TLS certificates, use secrets instead of config maps. Secrets are structurally similar, but values are base 64 encoded, and Kubernetes treats them with more care by default. Critical warning: base 64 is encoding, not encryption. Anyone with cluster access can decode it. You must enable etcd encryption at rest to actually protect values. Kubernetes has several built-in secret types optimized for common patterns. Opaque is the generic catch-all for passwords and API keys. Docker registry secrets hold pull credentials for private container registries. TLS secret store certificates and private keys for ingress. And service account token secrets handle pod authentication with the API server. Here are the field-tested rules every production engineer follows. Enable encryption at rest. Without it, your secrets are just base 64. Use RBAC to restrict secret access per pod. Rotate secrets regularly. And use external secret managers in production. On the don'ts, never commit secret YAML files with real values to Git. Never treat base 64 as encryption. Never give all pods access to all secrets. When choosing between environment variables and volume mounts for both secrets and config maps, consider this: env vars are simpler and work with every language, but the pod needs a restart to pick up changes. Volume mounts enable hot reload, files update automatically. Volume-mounted secrets also get secure file permissions by default. For serious production systems, don't store your true secrets in Kubernetes etcd. Use a dedicated secret management system. HashiCorp Vault is the gold standard. It generates dynamic database credentials, maintains a full audit trail, and handles automatic secret rotation. The external secrets operator bridges Vault to Kubernetes, watching your external secret resources and creating native Kubernetes secrets. Your complete cheat sheet. Create config maps and secrets with kubectl create using literals or files. Always decode secret values using base 64-D. Use kubectl describe to inspect what's inside. Use kubectl edit to update a live config map, and volume-mounted pods will pick up the changes without restarting. And always store secret YAML outside of Git. Episode 5 is done. You've mastered Kubernetes configuration from the cluster IP concept and DNS discovery, all the way to network policies and how kubeproxy works under the hood. In Episode 6, we tackle persistent volumes and storage, one of the most misunderstood areas. How Kubernetes handles stateful workloads, databases, and data that must survive. Subscribe, and we'll see you there.